Hi everyone, this is Mrs. Hayes and welcome to lesson 6.8, solve by completing the square. We just solved by taking square roots, so sometimes we might need to solve by completing the square first. So you'll see the square and then you can take a square root. That's the idea behind what we're going to do today. All right, let's do number one. Solve the following quadratic function algebraically. So we're solving, it's quadratic. First thing that comes to my mind is that you are looking for the zeros, and this function, y notation, needs to be replaced with a 0. So I like to keep the 0 over on that side, x minus 1 squared minus 16. In other words, I just set it equal to 0. Now I can see that there's only one x in the equation. If you only see one x, you are going to get x alone. And so I'm going to add the 16 over to the other side. I have x minus 1 squared equals 16. And now that the square is alone, sometimes I call that isolating the weird guy. And the weird thing in this case is the square. Now that he's alone, I can take a square root on both sides of the equation. And the square root gets rid of the square. Those are inverse operations. And when you take a square root, you put a plus or minus. I just sing it so that I remember it. X minus 1 equals plus or minus 4, because the square root of 16 is 4. And then finally, to get x alone, I need to add 1 over to the other side. And what better place to put it than in front of the plus and minus, so that I can actually say x is equal to 1 plus or minus 4. Which means 1 plus 4, that's 5. X equals 1 minus 4, that's negative 3. So I put the 1 in front of the plus or minus so that I have something to plus and minus with. And my two answers are 5 and negative 3. If you write them as a solution set, you might see it like that. Or negative 3 and 5. Okay, number 2, find the zeros of the quadratic equation. So I see a square. It can't be just set equal to 0 because it's got a 38 over here. So I got to do something with trying to find the zeros, and it says round your answer, which tells me it's not going to be nice. I'm thinking I got to use a calculator when I see that. All right, so here we go. I notice that there's only one x. So I'm going to get x alone. So the first thing I'm going to do is subtract 10 over to the other side with a 38. And I now have x minus 3 squared equals 28. Then the weird guy is alone, like I set up here. The weird guy is all alone on the left-hand side, so I can take a square root and put a plus or minus. So now I'm left with x minus 3 equals plus or minus the square root of 28. Since it's set up here nearest tenth, I'm going to not simplify. I'm going to just hit the calculator in a second or two. Once x is alone, I got to add 3. So x equals 3 plus or minus the square root of 28. This is going to give me 2 answers. So here's my branches and here's my calculator. 3 plus the square root of 28 is 8.2915. 8.2915. Dot, dot, dot. I'll round in a second. Back to my calculator. 3 minus the square root of 28 is negative 2.2915. Negative 2.2915. Dot, 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 dot. It said nearest tenth. Identify the number in the tenths position. Look to the right of it and determine whether that 2 should go up or stay the same. And it should go up, so 8.3 and negative 2.3. Those decimals will not always be the same like that. That was kind of a fluke. All right, so we have 2 answers for that one. Notice it was x squared, and we got 2 answers. That's not a mistake. Number 3, write the quadratic function in vertex form, and then show your work algebraically. So this is a blast from your past. When you see vertex form, you should know that that looks like x minus h squared plus k. And you should also recognize that that's sort of, back up into question 2, the form that we were looking at when we were solving these. That's why we're doing this. So we're going to try to put this in vertex form. So f of x equals x squared plus 10x plus blank, because I need to complete the square. I need to complete this square. And that's what we're going to do. So I have a blank there, and I'm just going to shuffle the 28 off a little bit further. When I add something in, I will need to take off that same amount. So I'm going to pretend to be factoring this for now, x and x. Splitting this evenly, the 10 split in half, gives me a 5 and a 5. And then when I square that, I get 25. If I add in 25, I immediately subtract the 25 out, because that makes a 0. Also, pay attention to this sign in front of the 10. When I split it in half, it was positive 5 and positive 5. So collecting the pieces here, the function is equal to x plus 5 is my square. Remember, these are the same things multiplied together. That's a square. And over here, the math that I can do is a 3. So plus 3 makes my vertex form. In case they ask, the vertex is -5, positive 3. But they didn't ask. That was just for fun. So remember, writing in vertex form usually means complete the square. And there's a reason why we did that if you turn the page. Looking at question 4, consider the quadratic. Find the zeros by factoring. So we're doing 2 separate things to this function. We're going to factor it, and then we're going to find the zeros also by completing the square, which leads to taking square roots to solve. So let's do the factoring. X squared minus 6x minus 16 equals 0, because we're finding zeros, so y will be 0. And then I'm going to factor this trinomial. I notice that there's no GCF, and so I'm just going to factor the trinomial into x and x, and 2 numbers that multiply to be 16 could be 16 and 1, 8 and 2. I'm going to stop there because I notice that 8 and 2, if I have a -8 and a positive 2, will multiply to be -16, if you look at those 3 dots that I just made. And if you add -8 plus 2, you get -6. And that's the middle term, -6x. Now that I have my factors, hopefully you're getting good at factoring, I'm going to set each of them equal to 0. Add the 8 over to the other side, x equals 8. I'm going to set x plus 2 equal to 0. This product must equal 0, so each of these pieces we set equal to 0, and we solve and get -2. So I have 2 answers, -2 and 8. Part B, find the zeros by completing the square. So I'm going to start with x squared minus 6x minus 16 equals 0. And then I am going to complete the square. So x squared minus 6x plus blank minus 16 minus blank equals 0. Pretend to start factoring. X and x, -3 minus 3. I split that 6 in half. That makes a +9 when I multiply, or when I square. -6 split in half and squared gives me my 9. Take off the 9, and then what do we have? We have x minus 3 squared, and this math is -25 equals 0. So that's the completing the square, complete the square part. Now I'm getting into the solving part. So I'm going to add the 25. I'm trying to get the weird guy alone. So I have x minus 3 squared is all alone, 25 over on the other side. I can take a square root of both sides and pull it a plus or minus. The squaring took out the square root. X minus 3 equals plus or minus 5. Add the 3 in front. So I have 3 plus or minus 5 giving me two answers, 3 plus 5, which is 8, and 3 minus 5 is -2. Same thing you got when you did it in part A. So they want you to think about factoring and completing the square and determine which is a better method. Well, in this case, I would say factoring was quicker, less steps, because it factored very easily. Completing the square, you had to go through a process and then another process. This was just factor, set them equal to 0, piece of cake. All right, so let's see if it's always the case. Why would we want to complete the square and do all that if we can just factor? So number 5, find the zeros by factoring. Here's our function, x squared plus 10x plus 5 equals 0. Trying to find 0, set it equals 0. Let's factor this, x and x. It's a trinomial. There was no GCF, so I'm trying to do a trinomial factoring. 5 and 1 are the only options for 5. Now the problem is, when I go to check if that will possibly give me a 10, a 5x and a 1x is only going to give me a 6x. Everything's positive. This is not factorable. And if that's the case, then we need another method to be able to find the zeros. So we're going to do completing the square. In this case, it will work. X squared plus 10x plus blank plus 5 minus blank equals 0. Start to factor this to make our perfect square. X and x, split the 10 in half, plus 5 plus 5. That gave me a 25 when I multiply those together. So I'm taking off 25. I have x plus 5 squared. This math, 5 minus 25, is a minus 20. And now I have to get the weird guy alone. I'm solving. So I did the complete the square step, and now I'm getting into solving. This was complete the square, solving. Add the 20 over to the other side. X plus 5 squared equals 20. The weird guy is alone. Take a square root and put a plus or minus. Now I have x plus 5 equals, it didn't say what to round to, so I'm just going to leave it as simplest radical form, a 4 and a 5, because that's my perfect square. I'm going to subtract the 5 in front, and I'm going to get x equals -5 plus or minus 2, because that's the square root of 4, with a radical 5. Now these are not like terms, so I can't combine them. I can't just add them together unless I calculate. So we're going to leave the answer like this, but realize it's -5 plus 2 radical 5 and -5 minus 2 radical 5. It is two separate answers. So definitely completing the square was the better method, and that's because it worked. The answers weren't nice, but we could leave our answer in simplest radical form or as decimals if factoring doesn't work. Keep in mind that factoring will only work if the numbers are nice. So if you have not nice numbers, then you can't factor. That's a factor right there. I'm trying to write the word factor. So anyways, this is another option for solving quadratics when things are not factorable. Thank you for working with me. Cool.